Function notation is just a fancy version of y. Before today, when you were dealing with an equation, it always started with y equals and then something. Okay, y equals 3x. Well, in function notation, we're going to be dealing with the same equations, but we're going to make it fancy, just like Pooh Bear here. Used to be that y was just regular Pooh Bear. But when we get fancy, we're going to call it function notation. This is pronounced f of x. Say it with me. F of x. Yeah. Don't say fx, don't say f times x, don't say f parentheses x, because that's not really telling me what's going on. Function notation is pronounced with an of in the middle of those two things. F of x. It might not always be f and it might not always be x, but that's how you pronounce that little saying. Okay? So we got that TikTok. We got Pooh Bear here telling us that we're just getting fancy. Fancy man, right? So function notation. The old way is that equations were just written with y's, x's and y's. Their coordinates were written with x's and y's. But in this new way, in this fancy way, ooh, fancy, function notation, instead of just a y, we're trading out all of the y's for f of x in both the equation and the coordinate. They become f of x's. It's a new way to write our output or our y values. Okay, so just like before, the y's were our output, our outputs, and our f of x still is our output. The input in a function notation is actually listed there for you. It's going to let us know what letter we are putting into the function. That letter's t, then instead of x's, your entire equation will have t's in it. But it's also going to tell us the number or thing that we plug in. It makes writing about equations a lot more efficient to use function notation. Now the f is not always an f either. You could literally use any letter in the alphabet, F, G, H, J, K, Q, W, X, Z, but it is, W, X, Y, Z, it is the name of the function. So this function is named f. We're going to be using multiple functions at the same time, and we need to know which function we're talking about. So instead of saying like the function on the top or the function third from the bottom, we're going to name them so that it's easier to talk about the different functions at the same time. The gist of function notation that we're going to be worried about today is being able to rewrite or evaluate functions expressed in function notation. So for example, let's say that my function I have is g of x. Its name is g. Its variable is x. And it's equal to 4x plus 2. Whatever is in those parentheses is what I'm plugging in for x. So let's say I had g of heart. What would I be plugging in to this equation? A heart, right? The function is g, so this is 4x plus 2. Whatever is in that parentheses is what you're plugging in. Right? So a second ago, g of x had an x in the parentheses and an x in the equation. And now, since in my parentheses is this heart, inside of parentheses, because parentheses are important, where the x was is now a heart. What happens if it's a star? G of star. What would I write down? Literally, we're just replacing the x with whatever is in that parentheses. But we also put our replacement in parentheses because it'll get confusing when there's numbers if you don't parentheses it. I mean, it can even be so weird if it's like a letter. Like, let's say we have the letter T. So we're just substituting out the x for a t. Absolutely. 4 parentheses t plus 2. Or if it's something complicated, not a big deal. Let's say it's literally my name. G of Quigley, or Quig, because it's shorter. Whatever's in that parentheses is what you plug in. So in this equation, you'd write down 4 parentheses Quig plus 2. Whatever is in that parentheses is exactly what you're plugging in. Easy, right? So what if it's a number? Do we panic? No, don't panic. If it's a number that's in there, you're still just plugging it in. 4 parentheses 3 plus 2. When we have only numbers, though, this is when we're actually going to do the evaluation. We're actually going to multiply this out. 4 times 3 is 12. 12 plus 2 is 14. So we would say that the following is true. We would say, therefore, g of 3 is equal to 4. And since I know that these are just inputs and outputs, I would also know that the coordinate 3, 4 is a part of my function. Where am I getting this 3 and 4 from? They're the numbers there, right? And didn't we say earlier that g of x is equal to the output? Yeah. So that's where I'm getting the x and the y. Function notation is just inputs and outputs in a fancy way with a little tuxedo on. And some shiny shoes. That's it. That's the gist of today. When you've got this written down, flip your paper over so I know you're ready to roll. So, evaluating functions. Guys, again, this is the gist of what we want to do today. When I ask you an evaluation question, I'm asking you to evaluate a function, all I want you to do is plug and chug. Have you ever heard that phrase before, plug and chug? It's really pretty easy because you're going to plug stuff in, but you're going to plug stuff in parentheses. Important note. And then you're just going to chug it out in your brain or in your calculator. You're going to be calculating things like we did 4 times 3 plus 2. That's the chug part. Plug things in, chug it out on your brain or in your calculator. It asks us to evaluate the following and write our answer as an ordered pair. So let me show you how this works. For number 1, f of x is equal to x plus 5, and we want to evaluate it given f of 2. So I write that down. F of 2 is equal to, but now what am I plugging in instead of an x? A 2. So I like to use parentheses when I'm plugging stuff in just to be sure I'm right. It's a little extra on this problem, but I want to make sure that I'm following, just make sure I never make a mistake. I just add them. So 2 plus 5 is, so we would say the function notation f of 2 is equal to 7. That's the plug and the chug. Plug is putting it in, chug is calculating it out, either in your brain or in your calculator. And to write it as an ordered pair, it's super simple because we already have our input and our output. Our input and our output. Pretty easy, right? We're going to do the first 4 together, so don't get lost if it's like, I don't know what's going on. I got you. Number 2 says f of x is equal to negative 4x plus 7, and we want to evaluate this when x is 2. So what are we going to plug in here? A 2. So I plug it in wherever the x is, wherever the x is in the original, you're plugging in a 2. A second ago, there was an x in the parentheses and an x in the equation. So now that I've replaced the x with a 2, I have to replace the x with a 2. That's the plug step. The chug step happens on your calculator or in your brain. And if you're a calculator person, I'm going to show you up here on the board. This is not going to switch over because I can't show this at the same time, so I promise I'll go back. But in your calculator, I know, gasp. In your calculator, you're going to be typing in exactly what is written on your paper. So exactly what happens after the equal sign is what you're typing in. So for me, that would be negative 4, open parentheses, 2 plus 7. Y'all try this. There's a lot of user error when we're doing this. So honestly, chug it out in your brain or plug it in your calculator.
Negative 1?
Absolutely, negative 1. So when we come back over here, Angel told us that it would be f of 2 is equal to negative 1. That's what we got when we chugged it out in our brain or in our calculator, which means we have the coordinate 2, comma, negative 1. There's our ordered pair from this function notation. Inputs, outputs, inputs, outputs. We might potentially have a graph on there. And that's cool because we're using functions which we know create lines and curves, and now we know how to use function notation to describe them. I'm not letting you go yet. We're going to do 2 more together, and then we'll try some on our own. Because if you look at number 3, yikes. Number 3 looks complicated, but here it's not. Watch. We're going to highlight, so I want you to put a little arrow or highlight or circle all of the x's in the original equation. Woo! It is. But no worries, because when I go back to function notation, what am I going to plug in here? Negative 3. So I have f of negative 3, and anywhere I see an x, even if that's more than once, I'm going to plug in a negative 3, specifically using parentheses. So important to use parentheses on this question. Because when you plug and chug this one into your calculator, if you do not use parentheses, you will not get it right. I'm going to let everyone write this down and we're going to chug it out together. Because we need to practice typing things in our calculator. Surprisingly rough. Lots of user error today. Right on. So once we've chugged it out in our calculator, we know that the f of negative 3 is equal to negative 3 halves, or negative 1.5, which means our coordinate is negative 3, comma, negative 3 halves, or negative 1.5. That's the ordered pair that goes with this function notation. If we were to graph this function, we're not going to today, we would have this coordinate on the line, the curve. Okay, let's check out number 4. We look at for all of the x's because that's what we're going to be replacing. This function's name is h. Not a big deal. They just named it something different. And what, actually, I want you to change this question, so I forgot to say this. I want you to mark this h of x equal to out. And I want you to write h of 2. I accidentally wrote the wrong thing. So this time, we're going to be plugging 2 into this function named h. But you're going to plug it in everywhere that the x's are. H of 2 is equal to negative 2 times 2 squared minus 7 times 2 with all of the parentheses. That's the plug step. Next is the chug step. So once we have this written down, I want you to chug it out in your brain or in your calculator. All that you're plugging into your calculator is the part that comes after the equal sign. I had some people confused about that earlier. You're just plugging in what comes after the equal sign. So we've plugged, and once we chug, we know that h of 2 is equal to what? Negative 22. That's the output when I plug that into my calculator. So we know that the coordinate, or the ordered pair that goes with this particular function notation problem, is 2, comma, negative 22. Okay, in the meantime, while you're finishing cheersing on your friends here, I want you to try both number 5 and number 6. On your own, number 5 and number 6. Take a second, try both of them, please. So let me bail you out on this first one. I see a lot of the same mistakes, and it's because of what I said, and I appreciate you guys following instructions. So when we're doing g of x equal negative 7, we have g of negative 7 equal to 2/3, and then I can't change the original equation. There should still be a minus 5 right here, but instead of x, I'm substituting in negative 7 in parentheses. So there is such a thing as double parentheses. That's allowed, and actually I need that to happen. So when we're doing this one, you got to use double parentheses because there's already parentheses there, and I'm putting more in.
So we always have to add more parentheses.
Yes. Anytime you're plugging something in, I want you to plug it in parentheses. When I plug and chug, so here's the plug, and when I chug it out, I should have gotten g of -7 is equal to, I believe, -8?
Yeah.
Okay, which means my coordinate is -7, -8.
You get the same answer though, without putting the extra.
In this particular one, you do. There are some you won't. Okay, if I bailed you out before you finish number 6, please finish number 6. Okay, so I got a lot of good questions just now on this one because of the double parentheses. And yes, you'll have a double parentheses going on because in this one, to do f of -7, if I'm plugging in a -7 where the x is, I can't change the original equation. I just make sure I replace the x with a -7. You will have a double parentheses and a double minus sign here. That's cool for right now. Okay, so if we chug that out, what did we get when we chugged this out? 50, which means my coordinate pair is -7, 50 for this particular one. Inputs and outputs. Is it -50 or is it positive?
Positive.
Okay, good. So here's what's cool about function notation is that it can take a lot of English sentences and translate it to math. And I told you all year long mathematicians are lazy. So this is another way that we can combine things together to write down less things. In this problem, we're going to let W of t, name of the function is W, the input is T, be the outside temperature measured in degrees Fahrenheit, T hours after 6 a.m. Here's what we know. We know that the input is a T and the output would be W of T, which translates to the hours after 6 a.m. and the outside temperature measured in degrees Fahrenheit. We can take function notation and translate it into English sentences. So we're allowed to keep a lot of data, a lot of things about this experiment we're running in very short notations. Number 7, I'm going to write down what it translates to, and I want you guys silently on your paper to figure out why. W of 0 equals 58 says at 6 a.m. it is 58 degrees outside. Think for a second. Don't say it out loud. That's the ugliest 58 I think I've ever written in my entire life. 58 degrees Fahrenheit. Figure out how W of 0 equals 58 could translate to all of that information. Okay. How do I know that when I put a 0 right here, it's 6 a.m.?
Because it's 0 hours after 6 a.m.
Yeah, exactly. Our T is hours after 6 a.m. So if it's 0, what time is it? 6 a.m. No time has passed. It is 6 a.m. And the output is the temperature outside. So the output is the degrees Fahrenheit. So knowing that, what does the middle one tell us? It's 100 degrees at what time?
6.
Ooh. 6?
12.
6 hours after 6 a.m., which would be 12 noon. So this one is saying at noon, or 12 o'clock p.m., it is 100 degrees outside, which makes sense. This is Texas. It's going to be warm in the afternoon. Very last one. These are both outputs, okay? What does this represent? W of 3.
The hours.
What hours after?
3.
3 hours after, so what time is it?
9.
It is 9, but it's the output. So we're going to say that this is representing the temperature at 9 a.m. is less than, what does this one stand for? W of 9.
9 hours.
9 hours after, so what time is it? 3 p.m. Yeah. So we're saying the temperature at 9 a.m. is less than the temperature at 3 p.m. That makes sense, right? It's going to be hotter in the afternoon. So it's 9 hours after 6 a.m. If we count up from 6, we have 7, 8, 9, 10, 11, 12, 1, 2, 3. That's 9.
Okay.
3 p.m. So this is just fun. This is not the main gist of today, but I think these are really fun problems because we're going to take real world things and we're going to put them into math, and you know math is cool, so like this is pretty cool. But we're going to do one more type of problem. We're going to skip the table at the end of this notes, but we're going to go over this graph. Okay? On this graph, we've been putting function notation as ordered pairs. So let's take ordered pairs and put it in function notation. We have a graph here. Its function is called f of x. Number 10 says find f of 2. This means to find the output when the input is 2. All right, so, well, here's where the input is 2. So here's where my line is. What's that coordinate? 2, comma.
2, comma.
Ooh, we start here. We got to go over 2 and up how many?
1.
1. So it's the coordinate 2, comma 1. Ooh, it's been a minute since I thought about an ordered pair, right? So if the input is 2, what's the output? 1. So we would say that f of 2 is equal to 1, which is exactly the coordinate that has now showed up on my graph. Function notation is coordinates. Coordinates are function notation. So how about if we evaluate f of negative 2? Where on my graph am I trying to find an output? If I go to negative 2, that's here. So if I find my graph, what's the coordinate of that point right there? Negative 2, comma 3, which means my output is 3. F of negative 2 is equal to 3 because the coordinate negative 2, comma 3 is part of my line. Coordinates are ordered pairs are function notation. But then I throw a curveball at you. In number 12, did I give you the input?
No.
No, I gave you the output. We're missing the x, so we got to work backwards. But I know that the output is 2. Here's where the output is 2, because it's on the level 2. What's the input right there?
0.
0, comma 2 is that coordinate. So the x value is 0, which means we know f of 0 is equal to 2. Coordinates are ordered pairs. Ordered pairs are just function notation, and function notation is the fancy version. It's pretty easy, right?
Yeah.
Okay, do me a favor. Glue this into your spiral. We're going to play bingo with function notation. Guys, this is going to be so much fun. What?